To understand set subtraction, let's think about how you learn to subtract numbers. If you wanted to know what 5 minus 2 is, you would start with 5 objects and then take away 2 objects. The number of objects you have left is the result of the subtraction. Set subtraction also involves a takeaway process. Let's start with sets A and B and find out what A minus B is. We'll have to consider the elements of the sets in our subtraction. We'll start with the elements in set A and take away from it the 3 and the 5 that are elements of set B. So A minus B is a set containing the elements 2, 4, and 6. Let's keep the same set A, but change set B just a little bit to contain the elements 3, 5, and 7. So how does that change the takeaway process for A minus B? Well, it really doesn't. We start with set A, we take away the elements that are in set B. And at least at first, this looks the same as the last problem. We can take away the 3 because it's contained in set B. We can take away the 5 because it's contained in set B. But what do we do about the 7? Even though the 7 is in set B, it's not in set A, so we can't take it away from set A. That means that A minus B is still going to be a set containing 2, 4, and 6. Now let's see how we can represent the same set subtraction using shading in a Venn diagram. Set A contains the elements 2, 3, 4, 5, and 6, and set B contains the elements 3, 5, and 7. To shade the part of the Venn diagram that represents A minus B, we still have to start with set A. So we'll shade in all of set A. But we need to take away from that what's in set B. So we'll take away everything that's in set B. And that leaves us with the shaded region that you see here, which contains the elements 2, 4, and 6.